Well, hello there. This is the Chapter 2 review session, or also known as the Chapter 2 study guide questions. So we're going to go through this with Doceri, and we'll see what we got. So here we go. Question number 1. I want you to consider the 4 criteria that are needed to define what a mineral is. So 4 criteria for defining a mineral. Can you think of one? Well, the first one that I have listed is minerals are inorganic, which means that they're never alive. Number 2 is what I have listed here is crystalline solid. They form not only crystals, but they're solid, and that therefore makes it crystalline. Number 3, minerals have a definite chemical composition, such as H2O. And the 4th criteria for defining a mineral is that minerals are naturally occurring. And this does include moon rocks, or rocks that are found on the moon. Okay, so based on this information, we're going to consider the mineral halite, or also known as salt. Do you think that salt is a mineral and therefore follows all 4 criteria we just discussed? What about this one? Sugar? Is it a mineral? And is ice a mineral? So here's question number 2. Blank combines to form blank, which combine to form elements, which combine to form rocks. So what goes in the first blank? Well, of course, atoms will combine to form elements, which combine to form minerals, which combine to form rocks. So actually, my diagram is completely wrong, so I have elements in the wrong place. And you probably found that out. Question number 3. This is a structure of an atom. And we need to label the parts of the atom. So, which part inside of the nucleus has a positive charge? What would you call that? Of course, that's a proton. Which one has a neutral charge or no charge? And of course, the E that surrounds the nucleus, these have a negative charge, and they are called electrons. So the first one, proton, positive charge, neutron, no charge. Electrons have a negative charge. And of course, this is the parts of the atom. The nucleus is not necessarily a part of an atom because it contains both protons and neutrons. Question number 4. We have a nice cute atom over here, which is next to another atom. But the atoms are not touching each other. They are actually transferring one of their valence electrons. So this is a type of bonding which is called what? So of course that's an ionic bond, which is soluble in water. Okay, here we have 2 more atoms that are getting along with bonding, but they are sharing one of their valence electrons. Therefore, they're forming a very strong bond, which is called of course, this is a covalent bond. Pretty much all metals or naturally occurring metals in the earth have metallic bonds. And the final type of bonding that is discussed in this study guide with Doceri is the micas. Micas have this type of bond, which is indicated by the H. So you can call that hydrogen bonds or van der Waals bonds. So here's question number 5. What is the difference between the atomic number and the atomic mass number of elements? So of course the atomic number is the number of protons in the nucleus, and the atomic mass number is the number of protons and neutrons in the nucleus. Here's question number 6. Number 6 has a beautiful chunk of graphite that you just mined from the earth. And of course, if you're lucky, on the right, it's not a carat, it's actually a diamond. So graphite and diamonds are both this. It starts with a PO. And it's called this word because they both have the same composition, but they have a different chemical structure, or crystal structure. So of course the word we're looking for is polymorphs. They're polymorphs. Question number 7, luster choices. What are my 2 choices for luster? And of course metallic and non-metallic is the correct answer. Question number 8, let's do the Mohs scale, starting with the number 1 is talc. Number 2 starts with a G, he's gypsum. 3 is calcite. 4 is fluorite. 5, apatite. 6, feldspar. 7 is the Q, quartz, Number 8 is topaz. Number 9 is corundum, and of course the hardest substance known is number 10, which is diamond. Cleavage versus fracture. Do you know which one means it breaks evenly along planes of weakness? And which word means that it breaks unevenly? Number 10, do minerals have special properties that are really, really cool? Of course, the answer is yes. Some minerals are magnetic. Some minerals will glow with a black light. Some minerals taste salty, and so forth and so on. So number 11 is a little bit different question. Of all the numbers that I'm showing here in the presentation, which number represents the number of known minerals found in the earth? And of course the answer is 4,000. Question number 12, I'm going to impress you with my chemical formula making creation abilities. This is a real chemical formula for one of your minerals. Is it a silicate or is it a non-silicate mineral? And of course the answer is it is a non-silicate mineral because it does not have Si in the formula. Here is another one. This is a non-silicate mineral as well, but you need to identify it as either carbonate or phosphate. And of course, he is a carbonate. Question number 14. This is not a stick figure. This is a structure that we talked about in the silicate umbrella. It has 4 oxygens surrounding a smaller silicon in the middle. And that structure is called a silicon-oxygen tetrahedron. Of course, tetrahedra with a at the end is plural. Based on that information, we have 2 silicon-oxygen tetrahedra, which are right next to each other. So if they're not touching and if they're not bonding or sharing oxygens, that is a type of structure that starts with the letter I. And of course, we're looking for isolated tetrahedra. Okay, that's the best I can do for a single chain silicate, which means that how many oxygens are shared between the tetrahedra. Of course, that's 1. If you have 2 neighboring oxygens that are shared among tetrahedra, you form a double chain. How many oxygens are shared in a sheet silicate? Of course, it's 3. And then all 4 are shared in a complex form. Okay, so let's explore this a little bit more with hornblende. Is hornblende a pyroxene or an amphibole? And what type of structure does hornblende have? So hornblende, of course, is an amphibole, and it has a double chain. Augite, which is a kind of a greenish-colored tinted mineral, is he a pyroxene or an amphibole? And of course, he's going to be the opposite of hornblende. He's going to be a pyroxene that has single chain structure. Okay, can you name one mica that we studied in class? And what type of structure does it have? So of course, you're looking for muscovite or biotite, and those are sheet silicates that are attached by hydrogen bonds. When you consider the mineral olivine, is it a low or high temperature mineral? It is a high temperature mineral. It forms at extremely high temperatures. So now we have 2 more questions to go, and I'm listing some elements here in docere. What are the 2 most abundant elements in the Earth's crust? And they are silicon, or Si, and oxygen, which is O. Of course, oxygen is the most abundant. And they combine to form the most abundant mineral, which is quartz. And the final question today, can you tell me some uses for carbonates? Well, carbonates, as well as such as calcite, is used to mine your road for concrete. And the uses for phosphates is for fertilizer to make your plants grow. And that is the end of our Chapter 2 study session.